In this video, we are going to talk about transformations of functions. So the basic question that we are going to address here is this. We start with a function y equals f of x. So maybe something like this. The ones that you start with are normally fairly simple ones. So here is the graph of y equals x squared. And then we are going to alter the function slightly, okay? So that's a little vague, but we will address that in the next slide. So we change this up a little bit. There's some things that we'll do. And then what we're going to ask is, well, what happens to the graph? Okay? How does the graph change when we change this function here? So as an example, let's say that we alter this function by replacing x by x minus 3 and then subtracting 2. So then the question is, okay, well, what happens to this graph? All right, and the graph actually moves over to the right. Actually, this is not the correct graph on here, so I need to fix that. So let's go here to Desmos and take a look at that. So y equals x squared is the graph that we start with, right? And then we are looking at y equals x minus 3 squared minus 2. All right, and we can see that the blue graph, right, is the one that's been shifted over 3 units and then down 2 units like this, okay? So that's the kind of question that we are going to try and answer. You mess with this graph a little bit, change it slightly, and then ask the question, well, what would the graph of the changed function look like, right? And so that's what we're after. And the reason is because then it's just a lot easier to analyze these graphs if you know about these transformations. These transformations happen a lot. And so it's easier, if you understand these relationships, it's easier to think about these graphs in later courses. Okay. All right. So when I say change the graph, okay, there's lots and lots of different ways that you could change the graph. But we are going to limit ourselves to these 6 ways of changing the graph. And I'm going to call those the 6 transformations. All right. So the 6 transformations, right, in words are, we can add k to the formula. So if we start off with y equals f of x, the symbol for that would be y equals f of x plus k. So whatever the original formula is, we add a number onto the end of it. Okay. The next transformation in words is we are going to replace x by x plus a number. Okay, so wherever there's an x in the original formula, we're going to pop that x out and replace it back with x plus a number. So the symbol for that in function notation is y equals f of x plus k. As a specific example of that, right, if I start with y equals x squared and then I replace x by x plus 5, right, this is the graph that we would get. The next transformation in words is we are going to multiply the formula by some positive number k. Now you might say, hey, well, why are you restricting yourself to positive numbers? Excuse me. And basically what it is that we will handle these negative cases separately, okay? It just turns out that it's a little bit easier to separate those out and think about it that way, okay? Because a negative number will actually have a couple of effects. All right. So multiplying a formula by a positive k, the symbol for that in function notation is y equals k times f of x. So if you start with y equals f of x, you just multiply the entire formula of f of x by some number. So a specific example of that is y equals x squared. Is that what you start with? And then you multiply the x squared by a number 5. Okay. Next up is we are going to replace x by some number times x, where k is again a positive number. So we're going to start with y equals f of x, then we would pop out the x and replace it back with some number times x. So for instance, if I started with y equals x squared, and I replace that x by 5 times x, and notice the 5 is in parentheses right here. That could be simplified to 25x squared. Right, so that's a specific example of this transformation. All right, and then finally the last two, the next to last one is to multiply the formula by -1. So here we would multiply the formula by -1, so put a minus there in front of the formula. And here is a specific example of that transformation. So we have y equals x squared, and so we would just multiply the formula by -1 to get y equals minus x squared. And finally, the last one is to replace x by -1x, or minus x, the opposite of x. The symbol for that in function notation would be f of minus x. In other words, we are plugging in minus x everywhere there's an x in the formula. All right, and a specific example of that is y equals x squared, and then I would plug in the minus x, and I'd get this. That can be simplified to y equals x squared. So here you can kind of see that really it didn't really change anything, whereas most of the other ones it did change something. Okay, so that's what we are talking about, right? In the very beginning I said this section is about, hey, you change the graph in some way, right? And then try to answer the question, what does that do to the graph, right? How does that change the graph of the original? And so we are going to restrict ourselves. When we say change the graph, it means apply one or more of these transformations, and that's it, right? Once you start getting out of away from these 6, things start getting much more complicated. Okay, so what I like to focus on, and what I think is the easiest thing to focus on when you're trying to understand how to work these problems, is the pointwise effect, right, of the transformation. So each one of those 6 transformations that I talked to you about has an effect on the points of the graph. Okay, so it's going to move those points around when you apply those transformations. And if you know the pointwise effects of those transformations, right, then that will help you to sketch the graph of the transformed function. Now, we're not actually going to be sketching graphs by hand or anything like that, but on the Newton problems that we will be working, they'll give you some points, and then you have to move the points around. Okay, and so like I said, I think that's the way to focus about on these problems and be able to do them correctly. All right, so we are now going to go through every one of those 6 and look at the pointwise effects and what they do to the graph. Okay, so first we're going to look at the overall effect of the graph, and then we'll look at the pointwise effect. Okay. All right, so first off is adding k to a function, right? And the symbol for that, again, is y equals f of x plus k. What's going to happen to the entire graph, right? The entire graph is going to get shifted vertically when you do that, okay? And it's going to be up if this k is positive, and it's going to be down if this k is negative. All right, and so here in this slide, k, the way I like to write it, and if you look in other books, you might see it written differently, right? But k could be either positive or negative, right? For these vertical shifts, it could either go up or it could go down. And now here, this is just a typo, so I should get rid of this here. So disregard this part right here. All right, so let's take a look at this graph right here. So starting with the graph of y equals the absolute value of x. So y equals the absolute value of x, not that. I want to sketch the graph of y equals absolute value of x plus 2. And you can see, right, that moves the graph and just shifts everything up 2 units, okay? And then if I did y equals absolute value of x minus 3, right, the green graph, you can see that that just shifts every single point on the graph, the red graph, down 3 units, okay? And so that's it for the horizontal shift. So when you add a number to the function, right, just take the entire function and then add a number. It could be subtract, right, which is like adding a negative. Then that's going to shift the entire graph vertically up if the number you add is positive, and down that many units if the graph is negative. Okay. So the pointwise effect, right, what happens is that you add k to the function. And if it's negative, right, it's kind of like subtracting. All right. So for instance, if I look at this point on 0, 0, right, that's on the red graph. All right, that point 0, 0 is right here. Then that point, right, is going to be shifted in this particular one, on the blue one, 2 units, right? The k in this shift was positive 2, so that is going to be shifted up 2 units. And same thing for every point on the graph here. So if you know, hey, the graph is just shifted up 2 units, it's really easy to figure out where each point goes, and then you know basically what the graph, the shifted graph, looks like. For the green point, right, 0, 0 was the point on the original graph. And so here the k is a negative 3, right? So 0 plus minus 3 is going to shift that point down 3 units. Okay, so I just add whatever the shift is, right, to the y coordinate. Okay, so that is the pointwise effect. All right, next up are horizontal shifts. So the second transformation that we looked at, right, was to replace x by x minus k. All right, and so what is going to happen there is that the graph of y equals f of x, the original graph, is going to be shifted horizontally k units, whatever k is. All right, and now it's going to be shifted to the left or to the right. And this part is a little bit confusing, right? It gets shifted to the left if k is positive, and it gets shifted to the right if k is negative, all right? So that's confusing to most people because it is absolutely backwards from what you think it should be, right? When the vertical shift, when you're adding the number on the outside, positive is up, negative is down, that makes sense, right? But here, when you're looking at horizontal shifts, it is backwards, okay? Now, the way I've written this one, it is critical that you write it as x minus a number, okay? That's why. So if you write it as x minus a number, it must be written exactly like that to get the k correct. Again, if you look at other sources, they might do it slightly differently than how we've done it. They might always write theirs as x plus some number k. I just think this way is easier to understand, okay? So let's take a look at an example here, all right? So first off, we want to start with the graph of y equals square root x. Looks like that. And then what we want to do is graph y equals x plus 2. So we can see, right, the transformation that has been applied of those 6 that we talked about. What we're doing here is we are replacing x by x minus a number. All right, in this case, it's written as x plus a number. So remember what I said is that this will shift the graph to the left. So if I have y equals square root of x plus 2, right, that's what happens. So this graph, y equals square root of x plus 2, gets shifted 2 units to the left. And again, you may say, man, that just doesn't seem right, right? Because of the fact that this 2 is a positive, right? It really seems like it should go that way, all right? But it's not like that. Now remember, the key to understanding this is if you write it as x minus a minus 2, right? Then we can see that the k for this one is minus 2, and it gets shifted minus 2 that way. All right. So if I look at the point on the graph, this red point, 0, 0, and I should have left that point there on the graph, and I'll color it red. So here's the point 0, 0, right, on the graph of the original function. And then what's going to happen is that that -2, right, is going to be added to the x coordinate. So it'll be 0 plus -2. Oops. And that point will get shifted two units over this way. Okay. So again, it's on these, you have to write it as x minus a number, and then you see that -2 right there. So to get the correct k on these horizontal ones, horizontal shifts, you've got to write it as x minus a number. All right, the next one was x minus 3. So if I do y equals square root x minus 3, so here I have replaced x by x minus 3. The k, right, in this case would be 3. Okay? And you're going to see that what I would do in that case is add k, the pointwise effect, I would add k to the x coordinate. So 3 plus 0 will give me 3. I'll try not to delete these points again so I don't have to keep redoing this. Okay. So if I add the k, right, in this case the k is 3, right, if I add it to the x coordinate, it shifts this point over here. So it shifts it to the right or to the left. Right, and I jumped ahead of myself, but that is the pointwise effect, right? If you find your k, right, the value for k, then what you would do, right, to figure out the pointwise effect is add k to the x coordinate. Okay. All right. The next effect, right, the next transformation is when we multiply the function f of x by a constant, k. Okay. K is going to be positive. And so the effect that this is going to have on the graph overall is that it is going to stretch the graph vertically if k is greater than 1, and it's going to shrink the graph vertically if k is in between 0 and 1. And remember, k, we're only considering the positive values. We are going to do the negative values as just negative ones. Okay. All right, let's take a look at this example. All right, so we're going to do y equals 1/2 x squared. So we're back to x squared again. All right, let me turn these off until we're ready to take a look at it. So y equals x squared is the red graph right here, and then we multiplied that by a half. So that's that transformation, right, where we multiply the function by some number. In this case, the number is in between 0 and 1, so you can see it kind of shrank the graph a little bit, right? The points are now, that were on the red graph, are now lower down, so it kind of smushed it, right, a little bit. And then y equals 3x squared. That's this purple graph. You can see it stretched it vertically. The points that were down here, right, got stretched and moved up like this. Okay. So the pointwise effect on this one is that once you figure out what your k is, which is pretty easy with these, you would multiply k times the y value by k to figure out where the point went. Okay. All right, so let's take a look at some examples of that. 0, 0 is not a good point to demonstrate this with, so let's do 1, 1. All right, 1, 1 is a point on the graph, right? Up here, I'm going to go ahead and turn the blue one on. All right, and so here, what we've done, if this point is on the original one, on the transformed graph, that point, to figure out where that point would go on the transformed graph, what we would do is to multiply, right, the y value by 1/2. So we would leave this 1 alone, right? It stays the same. And then 1 times 1/2 would be 1/2. All right, and so you can see that's where that point is located. So the point was up here, right, at 1, 1. When we did the transformation, it cut the y values in half. So now the y value of this point is down here at 1/2. All right, on this one, y equals 3x squared, the k is 3, right? And so the original point was at 1, 1. So that point is going to get moved to 1, 3, right? Because what we would do is multiply the y value of the point that's on the original graph by the k, which is 3. So 1 times 3 is 3. So you can see that point got stretched right all the way up here. And that happens to every single point on the graph, okay? Except if the y value is 0, right? Because 0 times anything is 0. So you can see that's why I didn't use 0, 0, because you can't actually see those points getting moved around by the transformation. All right? Okay. So pointwise effect is multiply all the y values by k. Okay, the next transformation is we are going to replace x by k times x, right? And so the overall effect on the graph that will have is that the graph is shrunk horizontally if k is greater than 1, and stretched horizontally if k is in between 0 and 1. So again, this one is totally backwards, and you'll notice the ones where you replace x by either x plus k or k times x are really kind of backwards as to how they work. Okay, so let's take a look at the examples here. Oops, I should have some examples. Let's see, I didn't pick out an original graph, so let's do x cubed. All right, so in this case, we're going to start with y equals x cubed, right? This red graph right here. And then what we are going to do is look at y equals f of 2x. So to do that, right, what we would do is we have y equals x cubed. We would replace the x by 2x. Okay, and so you can see what happened is that everything got kind of pushed right in here horizontally. So it got shrunk horizontally. Everything, these points right on the graph are now moved over here. And same thing down here. They're kind of moved in this way as well. All right, and then y equals f of 1/2 x. So again, we start with x cubed, and we are going to replace x by 1/2 x. All right, and then look at the effect. And you can see it got stretched horizontally. These points right now just got moved over here when we did the graph. Now you may say, hey, well, that can be simplified. Why didn't you do that? You absolutely can, and you probably do need to do that on most of these. But the thing is here I'm just trying to show you the transformations and how they work. So I'm not going to worry about simplifying these things right at the moment. On the questions, on the test, and on the homeworks, you're just going to be moving the points around anyway. So, okay. All right. So let's see. Back to the slides here. All right. And so now what you would do to figure out the pointwise effect when you replace x by k times x, right? So if this point x1, y1 is a point on the original function, then what you would do is you would divide the x by the k, okay? And that's where the point would get moved to. So let's look at an example of that. All right, so 1, 1 is a good point, right, to start with on the graph of the original one, y equals x cubed. So let's turn the label on that one. Kind of zoom in a little bit. Okay, and so what's going to happen, right? This point on the transformed graph, right? The y value will be the same, and then what we'll need to do is to divide our k is 2. In this example here, the blue example, we will have to divide this x value by k. So that would be 1 divided by 2. And that's where the point would get moved to. So this red point right here, this point on the graph of the original, to figure out where it goes, right, what you would do is divide the 1 by whatever the k is. In this case, you would get 0.5. Okay. All right, so on the purple graph, right, the k is a half, right? So if we start with this original point here at 1, 1, all right, and we want to figure out where it's going to wind up on the purple graph, right? Because this transformation, when we did this one, our k was 1/2, and we were replacing x by k times x, we would divide 1 by a half like this, all right? And you can see where that would wind up at. It winds up at 2, okay? All right, so here you don't want to leave this 1 divided by a half. That's a complex fraction, right? 1 divided by a half does come out to be 2, right? How that would work is when I divide by a fraction, right? Anything by a fraction, that's the same as changing it from division to multiplication and then multiplying by the reciprocal of the bottom number, right? So 1 divided by a half is the same as 1 times 2 over 1. I flipped this one over and changed it to multiplication. So I got 2. All right, so that's this point, right, gets stretched over here to 2. And so you can see that happens for all of the points on the graph, okay? They're going to get stretched to a new location unless their x number is 0, in which case they're going to all stay right here. And that happened again. All right, so that is the pointwise effect. Okay, so that leaves us the last two, the graph of y equals f minus f of x. The overall effect on the graph when you multiply or put a minus in front of the formula or multiply it by -1 is that the graph is reflected around the x-axis. Okay. So y equals x cubed is the one I want to look at, and that's good. I'm going to shut all of these off. Get rid of these. Not that. Okay, so here's the graph of y equals x cubed, right? And then when I put multiply it by a -1, right, then that is going to completely flip the graph right around the y-axis. It's going to reflect it about here, okay? So you can see that's the graph of y equals minus x cubed. The pointwise effect, right, that it's going to have is that you would just multiply the, sorry, that's totally wrong what I just told you. And it is reflected here, but we're talking about this reflection. So the reflection actually is from here to here. So maybe this is not a great example, but we'll just go with it. Okay, so the reflection, right, when you multiply by a -1 is that it's reflected about the x-axis. So sorry about that. In this case, if you reflect it about the y-axis, it actually comes out to be the same. So that's kind of got confused there about which example that we were on. So let's say maybe let's do y equals x squared here. That's a little bit easier to see probably. All right, so we'll switch to that one as an example. All right, so here we're talking about multiplying the entire function by -1. So it's going to reflect the graph right around the x-axis, okay? And that's what happened here. You can see all the points that were up here, they're all going to now be down on the other quadrant below the x-axis. All the points that were originally down here on the x-axis are going to get shifted up there. All right, so let's take a look. The pointwise effect, right? When you multiply the entire function by -1, it's going to multiply, right, the x coordinates by -1 to find where the points get shifted to. So if we start with this point on the graph of y equals x squared, right, then what we would do is keep the same x coordinate, right? So the x coordinate would be 1, and then we are going to multiply the y value by -1. So 1 times -1, right? That point will get shifted down here like this. So we would multiply the y coordinate by -1. Excuse me. Okay. And then the final one is where we replace x by -x. And that's the one that's going to reflect y equals f of x around the y-axis. All right. So in this case, I use the cube root of x, which I think does most I have to do is x to the 1/3. All right, so that's what the graph of the cube root of x looks like. And then what I'm going to do is start with x to the 1/3. And then I'm going to replace the x by -x. All right, and that's going to flip the graph right around the the y-axis rather, right? So this point is going to wind up over here, and points that were over here are going to wind up over here. So the pointwise effect on this is that if you have a point on the graph of the original function x1, y1, that point is going to get moved, right, to -x1 comma y1. So you would multiply the x coordinate by a -1 and leave the y coordinate alone. So change each x value to its opposite. All right, so for instance, this point 1, 1 on the original, right, what I would do is to figure out where it gets transformed, where it gets sent on the blue graph, is I would multiply the first coordinate by a -1. And so you can, and then leave the y coordinate the same. So this point will get sent over here. If I have, let's say another example, let's say I have this point, -1, -1 on the original graph. So you can see that's a point on the red graph. Then to figure out where it gets sent to, I am going to leave the y coordinate alone. So the y coordinate would be the same as the point on the original. And then I'm going to multiply the x coordinate by -1. So -1 times -1 is a +1. It gets shifted over here. Okay. So that's where that point would wind up. All right. So those are all the pointwise effects. I do have this handout. I will post this on Georgia View. Let me see if I can pull it up quickly now without wasting a bunch of time. So summary of transformations. Yes. So this will be posted on Georgia View, and I have all of the 6 transformations here. All right, so here they are in words. This is what it would look like in function notation, right? This is the effect that it has on the graph as a whole. Okay. and then these are the pointwise effects. All right, so I will be going through these problems. We're about to do a bunch of examples in the next videos. We'll do a bunch of examples on how this works, and then we'll do some examples on the Newton problems as well, so you can see how those work as well. All right. Okay, so that I think is it on this video. Yes. Okay, and we will separate these examples out into their own videos.